Due to a rather unfortunate lack of planning on my part, I ended up in a situation where my AIO didn't really fit. And so I needed to create some sort of riser. So I went and found some dimensions. This is a different model, but it's all close enough. What really matters to me is the placement of the screw holes. And I drew that out in Fusion 360, more or less faithfully to what the drawing said. I then exported that out to Bambu Studio to be printed on my H2D. But once I brought it into Bambu Studio, I quickly realized that the bracket was going to be just too big to print in one shot on the build plate. So I tried rotating it and seeing if it would fit at a diagonal, which it does do. But unfortunately, using a single print head, you can only use the region that is the overlapped region in the middle, and then either the right side or just the left side on a print like this. And obviously, as you can see, this particular STL is going to span both of those regions if I'm going to do this all in one shot. So look, there's kind of two options here. The first is that I can just break this thing in half and then go and print it as two pieces and then kind of glue them together, as I've done here. And this kind of works, right? But obviously it's a little bit annoying. I've got these connectors that will connect from this side into this side, right? There's some holes and some pegs, basically. That's not a bad solution. But what if I could get the whole build onto a single print, all in one material all at once? Well, I figured out a way to do it. And I think it's pretty cool, and I haven't seen anyone else do it this way quite yet. So what I did was I started by dividing the original down the middle. It doesn't have to be down the middle. It could just be anywhere in the overlapping area. And then if I just hide one of those, let's see here. I added a sketch where I simply drew on the faces. Let's get rid of this other sketch. I drew on the faces a grid on both faces. Then I extruded, let's flip from this body to this body, it will make a little bit more sense. I extruded out essentially a grid work of dowels that will go from one side into the other. And then I did the same in the opposite direction. From the top, I drew some connectors that will come down. And as you can see, they're then extruded downward. And then on this side, I drew a series of squares that were then extruded all the way across to create holes through these kind of interlocking pieces. I then used the join tool to essentially cut the fingers from the actual radiator spacer itself. So now if we look at, you can see that this shape has been cut out of it, right? If I add in the part that is the connector, you can see how the two pieces interlock. Now, if I just print it like this, the tolerances will be way too tight, and this is not going to work. So we're going to have to make either the holes bigger or the fingers smaller. But this shape, the way that it is, will allow the two pieces to be printed in place, interlocking like puzzle pieces, and hopefully hold each other very tightly. Next, I used the offset faces to pull the fingers back. So let's now get rid of this and let's look at the actual fingers. You can see that the fingers are now spaced just slightly away. So there's just a little bit of breathing room here. And now I'm going to do the same on the other side. You can see that there's just a tiny little gap there. If you look around the other side, you can see the gap's a little bit more contiguous the whole way down. Now we have another sketch. This sketch is essentially, let's get rid of all the bodies. you can see that the sketch is looking at each of the grids and putting a little border around them. Now the ones on the side, I didn't want to shrink the wall that is facing the outside of the object, just the ones that are on the inside. So you can see the border goes around on 3 edges instead of 4, and then in the bottom corner, it just goes around on 2 edges instead of 4. And there's 3 edges instead of 4, right? Let's put the bodies back on, get rid of that sketch. And now I extrude that. You look at the extrusion that was done here. That essentially is making these fingers a little bit smaller. So if you look at it very closely, you can see that there's just now a little bit of a gap here. This is the other side. So the first sketch was on this side, making the fingers on this side a little bit smaller. And then the second sketch is on this side, making this whole outline a little bit smaller. And then we have another sketch here outlining the pegs that go through the middle horizontally, just making those holes a little bit bigger. And then extruding that through to try to increase the size of those holes just slightly. I basically did 1/10 of a millimeter for the difference in size all the way around on my H2D. We now join these fingers to this half of this spacer. And if we bring both in and get rid of the sketch, you can see that the two are interlocked quite well here with just tiny gaps all over the place. There you can see that this piece belongs to the spacer that is not visible right now, and this piece belongs to the spacer that is visible right now. And the way that they are kind of hugging each other, they grip really, really tightly. Okay, so then let's get this thing out to Bambu Studio. And so now we've got it in Bambu Studio as 2 separate bodies. The 2 separate bodies are actually interlinked at the seam through the joints that we created. And essentially what we've done here is we've loaded both sides with the same material, PETG, and we're going to feed PETG into the left nozzle and into the right nozzle. And the effect of this, when we do a preview, the left side gets printed with the left nozzle, and then here in the middle, the right side starts to take over, and it prints the right side with the right nozzle. And if we look at just all the places where these kind of interlocking beams stack on top of each other, you can see that the green is always connected to other greens through the holes and then through pegs that come through, but the yellow is kind of intertwined with it in a way that it cannot let go. This is extremely similar to how Bambu Studio already does beam interlocking for painted surfaces, but it doesn't have this beam interlocking feature for models that are split in the middle like this. And I think this is a feature that they could easily add instead of having essentially a cut wherein you're splitting 2 objects and you can bind them back together by using connectors. Why not, in Bambu Studio, add a splitter where you can hand off the left side of the model to be printed with the left nozzle and the right side to be printed with the right nozzle. This would make it possible for you to use the entire print surface. Well, let's print this and see if it actually works. Ooh, it's done. Let's see how it came out. Well, for one thing, it looks like it printed successfully and fits beautifully on that print bed. I mean, exactly, just barely corner to corner, and there's our joint. It's my kind of custom interlocking beam. Let's see if I can zoom in enough that you can actually see what the heck's going on here. This zoom might not be of enough high quality that you can actually tell what's going on, but you can kind of see it. All right, let's see if it sticks together. Oh, it came Came off the bed nice. And, oh yeah. Oh, hell yeah. Oh, that is solid. That is rock solid. Beautiful, beautiful. PDTG, custom interlocking beams, both on both sides. Came out perfectly. Very happy with that. Wow. Shoot, that means that everything that I've ever printed that I made smaller because it couldn't fit on the whole print bed, or that I had to like break in half so that it would fit, means that I can fit bigger things in here. It means all of these crates are about an inch too small. Damn.